Hello again. In this video, we're gonna go into the source code and a little bit deeper into the code and implementation of ComfyUI. So if you are here, you're probably technical and you may have been a little bit familiar and used ComfyUI for a while and you just wanna go deeper. So that's what we're gonna do. The way we installed and had ComfyUI here is by using the default installation that we see on their GitHub repo. So we downloaded, extracted this, then we played with a few of the checkpoints, models. We set up ComfyUI Manager, so we know how to install plugins, how the directory structure works for ComfyUI. And now we are just want to go into the code itself. So let's navigate together. We know that we have these two ways of kicking off and starting ComfyUI, run cpu.bat, run NVIDIA GPU.bat. We can see that the entry point to the repo is main.py. It has a flag to tell it if it's CPU or nothing. So by default, it will try to run on GPU. So NVIDIA CUDA, if you have it installed. We can see that, of course, the Python environment that it's used, it's always the one that comes already in the zipped file. That's what makes it self-contained and completely standalone. So if we navigate to the repo, we can see that main.py, it's a standard Python file. We can also see that it's recognizing that an invalid Python interpreter is needed. Evidently, here we could select the Python interpreter, but I don't need it to do any of those changes. So navigating over what's happening is dynamically importing a lot of stuff, which makes sense. As you know, when you run ComfyUI, it automatically recognizes the different plugins that have been installed and then they get imported at runtime. So after you run the application, you can see that there may be a parameter, an argument to disable all custom nodes. That means troubleshooting. If something is evidently after you install a lot of plugins and nodes, sometimes it's necessary to start without any of them being activated. You may have issues finding all the possible modules. Obviously, that's one of the magical things about ComfyUI, how extensible it is, because it allows to import everything at runtime, listing all the models at runtime just by refreshing the UI, or of course restarting the service that provides the front end. We can see some of the arguments and parameters when we run the batch file, CUDA, PyTorch, different settings for PyTorch, some abstractions that they created for configuration settings, handling of memory, and this is how it tracks the work or the tasks asynchronously. So it uses queues in Python, I believe. So if we see where queue has been defined, queue item, absolutely. Flags, this is how it runs. Prompt queue, event loops. Obviously, I expected it to be asynchronous. It's using async.io, the standard Python way to make asynchronous implementations. And since it's a UI front end and it keeps track of progress on execution, and everything else makes absolute sense that it's using all these capabilities. Web browser, Python, uh, standard library um, approach that allows it to open the browser. This is why when you start ComfyUI, let's say it automatically opens the browser for you in a tab in localhost where whatever the server is running. Run sol. And this is really what happens at the beginning. It runs in an infinite loop, obviously, in an event loop, async IO. This is the main function, and it tells you the version that has been run. So we can see the server module. Okay. Obviously, we have web decorators for web, which is using IO HTTP. This is an installable pip install IO HTTP. It's not using Fast API, Flask, or anything else that you may be familiar with. So setting, of course, the different headers for responses, checking IP addresses. Very nice, using socket straight away to get address information, IP address, and other things to allow the service to be accessible by other endpoints, by the network. Creates a middleware, which sits probably in the way of requests to do pre-processing or post-processing on requests. It's serving, of course, JavaScript files. The UI, the front end, we shall see how it's being created. Routes, of course, we have WebSockets. No surprise, especially considering that the UI is so dynamic and you get progress and tracking of progress across your workflow. Not just on the colors around the boxes of each node within the workflow as it progresses, but also the bars on the top as the progress on your image generation and workflow, and each step is actually tracked and measured. So we see a lot of routes. Of course, image will be bytes IO, so that's why it needs to seek. It will, of course, identify the directories and where to save each of the images. Endpoints to upload the images, probably when you have nodes that allow you to submit your own image, you will have to store it, upload it somewhere. Same for masks when you just want to do outpainting, inpainting. Here we see a little bit of the image logic magic. It's probably using Pillow. I didn't see the import. I guess I skipped through that, but image is quite standard to use Pillow in Python. And yeah, we can see obviously the different parameters, handling channels, converting to RGB, seeking because it's using bytes IO. So it's a byte string buffer. And this is a standard to seek into position 0. So we can create a response of that image, and for downloading, let's say, dynamically without having to actually save it anywhere or establish a file name. The different channels, when you have an alpha channel, RGB with alpha channel, the size of the image. Yeah, I really like all the features and how slowly but steadily grew into a huge thing. ComfyUI really. We should track the progress from the beginning all the way when it started until what it became is really quite big right now, the code base, relatively speaking. Here are the imports. This is Pillow. This is a standard Python. Torch, of course, it's using PyTorch. PyTorch is standard for machine learning, deep learning, and creating the models. These are all, of course, ComfyUI specific packages. I shouldn't say packages, just modules or the structure of the imports. So you can create groupings of content. Import lib is a standard library, so probably this import should be higher with all the rest of the standard imports. So import lib allows you to dynamically import Python packages. Let's see what the last commit says. Custom node import. I have a plugin here on VS Code that allows me to see on each line the commit message for the last commit message related to that line. So whoever added last that line from the GitHub users. So we have nodes, node helpers, new updater, obviously new updater we can see, nice. So it just reads files, check if it updates. So it starts with this, copies files, and updates, latent preview, folder paths, nice. So this is good. Folder paths, evidently, for me, even without reading too much, it will define all the directories or subdirectories that are predetermined to have the different files that we need. In this case, supported PT extensions. That means all the models. We know that the models are their pickle files, safe tensors, PTH, bin, PT, CKPT. So when you download models, it's most certainly you've seen one of these formats. After you train a model, you need to save them. So what you do is you use some library or package or a standard, you serialize it, you store it, and then of course you can load it later and just use it. So when you download from Hugging Face or anything else, safe tensors seems to be the standard, the most used right now, and most of the checkpoints I download are safe tensors now. Cache helpers. So yeah, all these module is about folder paths and directories. Execution. Validate prompt. I should enable appearance. Let me enable so we can navigate faster. So we have the symbol. execute. This may be obviously execution, one of the most interesting, where it actually handles a lot of the execution of the workflow. Blacklist, I guess all these GPUs are not supported. Malloc is the standard C way of asking for memory to be allocated. And then, okay, on web, we see all the templates, images, JavaScript code, extensions, assets, utilities, fine. Just loading and extracting some configuration files. It's using YAML, JSON, of course, some merging JSON files, configuration settings, YAML and JSON. Easy from one to the other. Tests, styles, okay, default CSV, script examples. This is probably, oh yes. So you can use ComfyUI via its own API. So even though we use a UI to do and run and execute all our workflows, you could actually submit a workflow via an API. So you could have it running as a service anywhere you want. This makes a lot of sense since everything has been created as a web service. The UI interface is nothing more than a wrapper. So we have, of course, WebSockets, API examples. So you can do a REST API, WebSocket, more like real time. We see here WebSocket client, that's the repo. You can install it. The other four are standard Python libraries. Of course, the workflows, I can already see all the workflows are just JSON files. When you download or save workflows, you are just saving the JSON file. So the JSON is probably embedded in the output images. We see all the output that I had locally, notebooks, probably some examples, models. This is, of course, the standard models where I put a lot of this is my directory structure where I put the different models in different places. They get automatically recognized, so it doesn't really matter on the directory tree structure. Just trying to keep it clean, considering that I started downloading and testing so many models on multiple things. Input, also a lot of information. Custom nodes is the big one. All the nodes that have been installed via manually, only ComfyUI Manager. I believe that's the only one I installed by hand. All the rest have been via ComfyUI Manager, one by one. Whenever you upload or use a workflow and it has some missing nodes because it's using custom nodes that people created, you can use ComfyUI Manager to actually install and identify which nodes you are missing from the workflow and installing them automatically. One of the risks is that they can have conflicts between each other. That is probably because of the naming conventions that they use, the name of the classes or functions or callables that they may use inside, importing them automatically. So if you have two nodes that are named exactly the same, evidently they will have um, the Python interpreter wouldn't know which one to actually use out of all of that. So more configuration, Comfy extras. Okay, lots of modules, PyTorch. Interesting. Some implementations for scaling, sampling. Quite a lot of logical implementation. Not everything goes just on the models. All the nodes webcam. So doing this exercise, we can absolutely copy paste one of these example nodes and start learning and trying to make simple nodes for us to get familiar on how ComfyUI will ultimately work if we wanted to create or if we have an idea in mind on the generation. Evidently, ComfyUI is nothing more than an abstraction, a very nice one, a UI, where we can have a pipeline, right? The workflow is nothing more than a sequential pipeline of ordering of tasks or execution. If you're listening to this, you're probably familiar, with Airflow and Luigi and Dask and a lot of other Python libraries that do distributed computation or pipelining. If you worked or heard about um, data engineering, of course, and DBT as how to process data. So ComfyUI is absolutely doing all of that and simplifying the process. So we can think about functions that call other functions, and in ComfyUI we could generate our own workflows in Python code. Absolutely, and that's what people before ComfyUI used to do, right? Like we just go on Hugging Face, download the model, and just set up the parameters, create a file to configure something, and of course, run a set of a for loop to generate multiple images, varying the prompt and whatever else we needed. So Torch. I mean, hopefully this was helpful for you. It's definitely been helpful for me. This is the first time I look into the ComfyUI uh, repo, the code in detail. I have used it quite a bit, but I never cared to look at all the magic that the community has built. I came across ComfyUI quite late. I didn't have a need for it, simply using Python to use the models for image generation and many other things. Hugging Face absolutely has so much, and I can see how ComfyUI can be usable for many models and not just image generation, but definitely I can see how it absolutely shines with the image generation and video generation. So adapter, tokenizers, LDM, padding, logging using NumPy, configuration, nice. Blocks. These are probably just Not sure this came, I wouldn't say this came with ComfyUI. Maybe this is something that has been installed for some reason. That seems to be my impression. But regardless, it's in PyTorch. Yeah, indirectly, it's not importing it right here. Time steps. It has a lot of implementation. Convolutional 3D, torch. I did not expect it to have so much actual ML, deep learning code or PyTorch code. I would have expected it to leverage a lot more, the models or some abstractions or filtering within the workflows than actual implementation. Flux, control net. But again, I'm not even sure, right? Like if all the code we're looking at under LDM actually comes directly from the default ComfyUI. At this point, of course, I'm looking at my code base after I installed a lot of things, right? And it's been a while, so if that almost closes down, and then we can go even to see on GitHub if they exist on the default installation or not. There is no need to do anything else. More routes, configuration, uses caching, regular expressions, nice login, timestamps. Absolutely solid. Directories, recursively looking for directories, identifying the models dynamically, getting the list, model manager, so makes sense. So probably this gets called by the UI, and that's how you can filter and identify the models when you press F5 and just see the new models that you may download and put, as long as you place them in the right directory, that can be configured in a YAML file somewhere. Okay, app, API server, routes, services, utils, file operations. Okay, details about the file size and those kinds of things. Terminal services, subscribe, unsubscribe. That would make sense, I guess, for WebSockets, or if you have a notifier event like an observer pattern and you want to notify when things happen. Okay, if not in allowed directories, you can list all the files, internal routes, and see what do we have, /files in a given directory. You can send by parameter logs, probably to be able from a route to see the logs of what's happening. You can subscribe to see or get real-time logs and output. And you can, from an API, see all the folder paths that have been configured. Maybe this come from a configuration setting. Then, of course, GitHub and CI/CD. Okay, let's go to the web. Let's see if we go to Comfy Oh yes, here we see quite a few things. Let me zoom in. We have just a few. Node typing, examples, example nodes, an example node that just add one to an input integer. Perfect. So this is actually one of the things we were talking about. If we wanted an example node to start learning about how to build nodes for ComfyUI and what we can do, this is exactly the purpose of what we have right here. Inspect is a standard Python library. So, and this is, of course, custom from ComfyUI. You copy paste, you can use this one, input options, put types, require hint, readme, type hinting for ComfyUI node development. Very nice. We were looking at LDM and we thought that there was a lot here and we weren't sure. This kind of is telling us that absolutely it comes by default with ComfyUI. This is not a plugin or nodes that I have installed. This file is part of ComfyUI. Nice doc strings, guys. Absolutely. Torch Vision, PyTorch, creating your own neural nets. Quite nice. Good stuff. Okay, well, I think we should leave it here. This was a great first overview from me, and I'm sharing it as a video. This is how I would normally take a quick look at an initial repo to try to get familiar my head around what's going on, what the directory structure is, what the modules are being used, some basic dependencies. Of course, for libraries and dependencies, ideally you just go to requirements.txt, but it's much different when you actually see when and where it is used across the different modules and the different packages and how the code base has been organized, right? So absolutely quite a nice piece of code, super useful. Another show of what the community can build, when a lot of us and people just get together to write some of these things. So as usual, information on the description. Thank you very much for watching. Hopefully it was helpful to navigate this with me. And see you on the next video. Thank you for watching.